Welcome to Unit 1, Module 3. In this module, we will be learning about measurements. The learning objectives for this module are to learn how to use the SI unit system for measurements, record measurements and calculations using the correct number of significant figures. We will also be discussing accuracy and precision, and using dimensional analysis to convert units, and also learning about Fahrenheit, Celsius, and Kelvin temperature conversions. We will begin by doing a review of scientific notation, just in case it's been a while since you've learned scientific notation. Before we jump into scientific notation, we will review decimal notation. This is the standard format that calculators output by default, where there's a decimal point that separates the ones place from the tenths place. In other countries, it's not a decimal point, it's a comma, but in the United States, that is a decimal point right there separating the ones place from the tenths place. Every single digit in this number has a place that tells us what it represents. So the 3 is in the tens place, making sure that this would represent 30, not 3. And the hundreds place, that 2 is in the hundreds place, so that's a 200 rather than a 2. So that each place here tells us the relative size of that digit. There's digits behind the decimal point that each have a TH in the name, and so that tells us it's behind the decimal point. When we go into scientific notation is a great way of writing numbers when we're dealing with either extremely large numbers or extremely small numbers, because then we don't have to sit there counting how many zeros are in the number to try to figure out which place the 1 is in. So in scientific notation, you are allowed one digit in front of the decimal point. And that one digit has to be between 1 and 9. You can't have a 0 there. So if it was a 0, you'd have to move it over one more so that your one digit is between 1 and 9. After that, you list all the other significant digits in the number, and then you go times 10 to some power. This times 10 to some power tells us what we would need to multiply this number by in order to reach our real number. So this is saying that we need to multiply by 10 to the third power. 10 to the third power is 1,000 because 1,000 has 3 zeros. And so we would need to multiply 1.2345 times 1,000 in order to reach our true number. And so that would be 1, 2, 3, and so this represents 1,234.5678. And so this is the same number that was on the decimal notation slide, only now it's written in scientific notation. A positive exponent tells us we need to multiply by a number, and our number will be larger than 1 in the end. If we're multiplying by a negative exponent, then that is the same as multiplying by 1 over 10 to whatever power it is. So if it was 10 to the minus 3, then we would multiply by 1 over 10 to the third, or 1/1000th. And that will make our number smaller than 1. So when we're interconverting between decimal and scientific notation, we need to figure out how many times we need to move the decimal point in order to interconvert our number. So this first number, these are big numbers, and so we know our exponent has to be positive. The number is greater than 1, and so our exponent has to be positive. And so I can go ahead and write out the number. I'm going to have to move the decimal point from here to there. And so that's 1.392, and then a whole bunch of zeros. And we'll learn about significant zeros in another video. But these zeros are not significant. So I'm going to go ahead and move it from, we know the decimal point had to be here because that's after the ones place. And so now we have to move it to here. And so now we have to count to see how many places that is. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that means I'm going to have to multiply 1.392 times 10 to the 9th power in order to replicate this number. If we do something similar for a number that's smaller than 1, we know that our exponent has to be negative. So since this number is less than 1, our exponent is negative. I know that in scientific notation, I'm allowed one non-zero digit in front of the decimal point. And so that's going to have to be here. That 0 after the 7 is significant. We will learn about significant zeros after in another video. But that is 7.0 times 10 to some power. I know that 7.0 is much larger than all these zeros and then 7.0. So I'm going to have a negative exponent of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 10 to the minus 11 meters. So the diameter of a carbon atom is 7.0 times 10 to the minus 11 meters. Going the other way, we can look at the exponent and know that I have to multiply 2.998 times 10 to the 8th power. 10 to the 8th power is going to be a very large number. That is 10 to the, with 8 zeros. So that's times 10 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And so this is going to be a very huge number. So 2.998 times 10 with 8 zeros is going to be really big. And so I can go ahead and write out 2.998 and then go 1, 2, 3, 4, 5, 6, 7, 8. And then each of these little humps, I can add in a 0. And then I can clean this up and go, okay, if this is my new ones place, put my unit on, this is my ones place, that's 1, 2, 3, comma, 1, 2, 3, comma. So that helps us kind of reading the numbers if we separate out every 3 digits from the ones place with commas. So it's a very big number. All right. For our next one, it says the diameter of a DNA helix is 2.2 times 10 to the minus 9 meters. So the exponent's negative, and so I'm going to have to pretty much divide by 10 9 times. That's going to make my number really small. And so you can think of this as 10 to the 9th, and that's 2 times 1 over 10 with 9 zeros. 2, 3, 4, 5, 6, 7, 8, 9. Why did I write a 9? 9 because I was trying to write 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's going to be a really small number. So I got to take my 2 and move the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9. And move it to its new location. So that's 1, 2, 3, 4, 5, 6, 7, 8 zeros. So you can't just put 9 zeros because then you'll have one too many zeros. You have to remember that the decimal point was behind the 2, and so one of these movements of the decimal point had to move past the 2. So there's really only 8 zeros and then the 2. If you go through the PowerPoints without listening to the presentation, the correct answers are typed. They're just covered up. All right, so let's do a practice problem. I want you to go ahead and pause the video and try to work out these problems on your own in your notebook. Then go ahead and play the video and check yourself. Okay, so hopefully you are unpausing the video in order to double check yourself. And so in this first part, we're trying to write these in scientific notation. In scientific notation, we're allowed only one digit before the decimal point. And so I have to change this to 1.234. Then I'm going to write 10 to some power. It's going to be a positive exponent. And so I have to move it 2 times. I know it has to be a positive exponent because 100 is more than 1. So 123 is more than 1. For the next one, we got 2.525 times 10. My exponent's going to be positive again. And now I just have to move it once. And so that's times 10 to the 1s. For our next one, our decimal point is in the correct position, but we still have to write in scientific notation. 10 to the first power is going to be like multiplying by 10. 10 to the minus 1 power is going to be like dividing by 10. So we need a 10 to the 0 power. 10 to the 0 power is equal to 1. And so that's not going to multiply our number by anything but 1. So any number times itself is just itself. Now for our next one, I know that my number, my decimal point, has to move here because I'm only allowed one digit before the decimal point. 1.23 is more than 0.0123. So I know my exponent's going to have to be positive, not positive, negative. My exponent's going to need to be negative, and then that's going to be minus 2. So that I would divide 1.23 by 100 in order to get back to 0.0123. All right, now we'll go the other way from scientific notation into decimal notation. When we are multiplying by a negative exponent, that is like dividing by 10 4 times. And so I'm going to have to go 1, 2, 3, 4. And so that's 0.3 zeros. And there we go. After that, we're going to do 4.0 times 10 to the 0. 10 to the 0 is 1. And so any number times 1 is just itself. Then we have 3.3 times 10 to the first power. And that is going to be 3.3 times 10, which is 33. Now, if we go through the PowerPoint, we can double check me. Make sure I counted things correctly. Yep, looks good.